Hi, this is Mark Maclaine. I'm just going to do a quick introduction to solving equations. Now, the way I think of equations is kind of a little bit like that old game of pass the parcel that children play at children's birthday parties. And imagine that you have a sort of present that's been kind of wrapped up here. Then what will happen is the parents at the party will then wrap that in another layer and another layer and another layer of wrapping paper. And essentially the children at the birthday party then will pass it round in a circle, and when the music stops, they will unwrap one of the layers. So they just take off one of these layers, and then once they've done that one, pass around for a while, then they take off the next layer and the next layer, and eventually they get down to the present at the bottom. Now, I do understand that algebra doesn't sound anything like a game at all, but essentially it works in a similar way, in that for example, say you have a letter like X, what will happen to that X is it'll be wrapped in a certain operation. Now, that operation could be, for example, let's have a look, maybe, say, times by 5. Okay, so that operation there would be timesing it by 5. Then what we might do is we might legitimately say add 3 to it. Now, what would that look like? Well, we'd have our X, and timesing it by 5 would be like this, and then adding 3 would be like this, and that's following BIDMAS. There we go. So that would be our equation here, and it would see it represented by this. Now, what we do with algebra is when we're solving equations, we work backwards. So if we're trying to get the x on its own, the first thing we have to do is get rid of this plus 3. Okay, and then we have to get rid of this times by 5. And the way we do that is by using opposites. So what is the opposite of adding? Well, it's subtracting. What's the opposite of subtracting? It's adding. What's the opposite of multiplying? Well, it's dividing. And the opposite of dividing is, of course, multiplying. Now, for example, if something's squared, the opposite to that is square rooting. And, of course, the opposite of square rooting is to square something. Now we'll have a look at these questions that I've created just here. So, for example, now how does this work in practice? Well, the first thing is I look at this equation number 1 here, and I see that 5x plus 3 is equal to 43. Now the key to algebra is, this is it, algebra is kind of like a game, not a fun game, but essentially the game is to get the x on its own on one side and all the numbers on the other. And then we'll have like x equals, say, 12 or x equals 18 or something like that. Now, let's have a look what x actually is in this case. Well, the way we do this is I often use the arrow method here, where essentially you draw a line just underneath the equals to another equals, and then eventually you'll just draw another line underneath that. Now, some people like to sort of put an arrowhead on it, which is fine if you want to, but essentially it's just showing that you're essentially going to keep one side of the equation. So, for example, this 5x plus 3 is separate from the 43. So, say like in a game of tennis, there is a net in the middle. You keep one side of the equation completely separate from the other. So what we're doing here is that's what that red line is. Now, of course, you don't have to do it in red, but that's just a colour just I'm using just to kind of separate the two. Now, the key here is understanding that what we need to do is we need to get this x on its own. Well, how we do that is we're going to have to get rid of this plus 3 and this times by 5, because essentially what's happening here is the x is being times by 5, if we follow BIDMAS or BODMAS, it's being times by 5, and then you're adding 3 to it. So hopefully you can see that it's 5 times the x, and then you'll add the 3 to it here. Well, we need to do this in the reverse order. We need, like the pass the parcel where you were unwrapping those outer layers, we need to get rid of the last thing that was done to it first. So in this case, what we're going to do is we're going to work backwards through these operations. So the opposite of adding 3 is subtracting 3. So what we then do is we subtract 3, but we have to do it to both sides. So the number 1 rule of algebra is, or solving these equations at least, is what you do to one side, you have to do to the other. Say, for example, myself, Let's have a look. Here's Mark, that's me, and my friend Andrew are the same age as each other. Well, I can't then go add 2 years to my age without doing the same thing to him, unless he sat in some kind of time travel thing where time stopped. But in normal case, we can't just add, you'd have to add 2 to both sides to keep our ages the same as each other. Okay, so what's going on here now is we have to minus 3 or subtract 3 from both sides, and that gets rid of this add 3. Okay, so this will actually get rid of this add 3, meaning that we are left with just 5x on this side. Now, I'm not going to worry too much about the numbers on the other side for a moment. The key here for me is just to make sure I'm explaining that I'm getting the x on its own. Now, the next thing to be done, because remember we're working this way through the equation, is to get rid of the times by 5 here. Well, the opposite of timesing by 5 is divide by 5, even though I've written divide by 3. There we go, divide by 5. Okay, so what we've now got is I'm going to divide this by 5, because 5x's divided by 5 leaves us with 1x. Well, we can just write that as x there. But remember, what we do to one side, we have to do to the other. So let's have a look at this 43 here. Well, if we subtract 3 from that, we're left with just 40. And if we divide that by 5, we get 8. So x is equal to 8. Now, what I often do is I recommend people putting that into the equation again and just double checking. So what is 5 times 8? Well, that is 40. And then we're going to add the 3 here, which gives us 43. So we know that this is correct. And there's my little smiley face there. Okay, let's have a look at question 2. Now, we're not using x in this case, we're using an m, but it's the same thing. So what we're going to do here is, if we have a look at this, we can see we're trying to get the m on its own. So eventually we're going to have m equals something. We try and get all the numbers over to one side and all the letters over to the other. Okay, so let's have a look at what the answer is. Okay, so I'm going to have a look at this. Now, what's actually happening here, those of you who are happy with BIDMAS or BODMAS, or the order of operations, will see that what's happening to the m here is it is being multiplied by 3, okay, and then we are subtracting 12 from it. So whatever m is being multiplied by 3, and then we're subtracting 12 from that. Right, so let's do this. So there we go. What we're going to do is do the opposite. We're going to work backwards through this, and we're going to get rid of this minus 12. We're going to get rid of the minus 12. Now, the opposite of subtracting 12 is adding 12. So that's what we do. So we add 12 to both sides. Okay, and that will leave us with just 3m, because by adding 12 to a minus 12, it makes 0, so it doesn't have to be written anymore. And now we have 3m on this side. 24 add 12 is 36. Now what we want to do is just get the m on its own. Okay, and because it's being times by 3, remember we're working backwards, we're now going to divide by 3. That 12 was plus 12 there. So we work backwards through it. So what we do is we divide both sides by 3, and hopefully you can see that m is equal to 12. Now, sometimes what we get in some questions is we get x's on both sides. So we've got an x here and an x here. Again, the same rule applies. We want to get the x's all onto one side and the numbers onto the other. So what we do is this. Now, what I do is I say, which side has the most x's on it? Now, this is a positive 8x, and this is also a positive 2x. So I would say that the positive 8x has the most x's right now, because 8 is higher than 2. If it was a negative 8, then it would be lower than 2, but we'll come to that in a second. So what we've got here is 8x and 2x. So what I'm going to try and do is take this 2x over to this side. Okay, I'm going to try and move it over to this side of the net if it was tennis, but essentially that's what I'm going to do. So what I'm actually going to do is subtract 2x, because this is a positive 2x that is being added to this 36 here. The opposite of that would be taking away the 2x. So what we're left with is, when I do 8x minus 2x, I'm left with 6x's. Okay, and that the plus 6 is still there, and the 36 on this side is still here. Now, I can write plus 36, positive 36, but remember, just 36 means the same thing, so very often we don't write that. But if it's easier for you, you can put a plus in front of the 36 if you want. It just means it's positive. Now here, again, what I'm trying to do, just like the last questions, is I would like to get rid of this plus 6 here. We're trying to get all the numbers onto one side. Now, if we follow the BIDMAS, what's actually the order of operations that's actually going on for this x here, it is being multiplied by 6, and then it's having 6 added to it. So if we're going to work backwards through that, we want to minus 6 to get rid of that, and then we'll want to divide by 6 to get rid of that. So what's happening here is I'm going to minus 6, because remember we're working backwards through those order of operations to get the x on its own, and we're left with 6x on this side equals 30, and then all we have to do is divide by 6 on both sides, so what we're left with is x is equal to 30 divided by 6, which is 5. Okay. Now, let's have a look over here. What we've got is one last question that I'm going to have a look at. Again, the same thing. I've got the m's. I want to get them all over to one side. But which side has the most m's? Now, some people are obsessed about bringing all the letters over to this side. But sometimes that can make it more difficult because it can create negative answers. So what I do is I often recommend that you move them over to the side that has the most m's. And in this case, that would be that one. So we're going to be trying to take this positive 3m over to that side. And the way we do that is we subtract 3m from both sides. So let's have a look at this. So what's left on this side is a negative 10. Now we do have to keep that minus because it's negative. And then we now have 5m minus 3m, which is 2m, plus the 30 is still on this side. Now, what I want to do is I want to get the plus 30 over to the other side. So I'm actually going to subtract 30 from both sides here because I want to get rid of this this 30, and what that leaves us with is just 2m on this side and minus 10 minus an additional 30. So if you're at minus 10 degrees and it gets colder by 30 degrees, will actually give us minus 40. Okay, now all we have to do to get the m on its own, because we're just trying to get the m here, is we just divide by 2. Okay, so we divide both of those by 2. So what is minus 40 divided by 2? Well, I always ask myself, what's 40 divided by 2? And that's 20, but because it's negative 20. And so then if you really want, you can just write m is equal to negative 20, because of course if negative 20 is equal to m, then m is equal to negative 20.